All right, folks, it's Bass Action back in action here. In this video, we're going to talk about how to find the distance from a point to a line using our coordinate geometry. Just like in the previous video, I have already plotted the point that we want to measure the distance from and plotted the points that we're using for the line that we want to measure the distance to. So before I get into the actual algebra on this, we want to think through what's happening, because if you're not thinking about what's happening, you're going to be forced to just memorize the steps. And when you go to memorize the steps, it starts to actually get really overwhelming. So we're going to actually think about the steps in reverse. If I want to find the distance from a point to a line, I need that distance to be measured on a perpendicular, because our shortest distance, which would be the distance we'd want to find, because that's going to be the most accurate, has to be measured along a perpendicular. Now, that means that I'm going to need, if I want to measure this distance, I'm thinking about measuring the distance along a line that looks something like this. Now, mine's not going to be exact because I'm just kind of sketching this in for thinking. So I need this to be measured on some kind of a perpendicular. So if I was going to measure the distance, I would calculate it from this point to whatever this point is. Well, in order for me to get this point and calculate a distance, I need the equation for this line. And then I need to know where this blue line is going to intersect the original red line. So there are many things we need. We're going to need the equation for the red line. We're going to need the equation for the blue line. We're going to need where they intersect together. And then, and only then, can we actually calculate that distance. Now, I do want to point out that if I ask you to find the distance from a point to either a vertical line or a horizontal line, there's no actual math that needs to be done. If the line that you're measuring the distance to is vertical or horizontal, you can just draw a picture for me and count it out. That's it. That's all you're going to have to do. But when your line is not vertical or horizontal, for example, like this one, you're going to have to go through all the steps. All right, let's just jump in then. Let's first write the equation for our line that goes through AB. So similar to what we did for perpendicular bisector, I need to start off with I've got to have my slope, okay? So I'm going to go ahead and quick calculate this slope. And I'm going to do a little bit more mentally here. I can see that 3 minus my -3 is going to be 3 plus 3, so that's going to give me a 6. And then I'm going to have a -5 minus my 4, so that's going to be a -9. I'm going to reduce that fraction, of course. I need to reduce that, so that gets me a -2/3. My slope is negative. That matches the picture that I have, so I'm in good shape. When I go to set this up in my point slope form, I'm going to have some fractions here. Didn't mean to write that equals there quite yet. I'm going to choose one of my points to make my line go through. It doesn't matter if I choose this point or this point. I can pick either one. I'm going to pick this one for no real reason. They're both equally the same. So when I set this up with point slope, I'm going to say y minus 3. I'm going to use that slope that I just calculated, and now I'm going to write x minus the -5, so x plus 5. Now, if I try to distribute this -2/3 here, I'm going to end up with some fractions. I don't want to create more fractions, so all I'm going to do is I'm going to rewrite this as a -2/3 x plus 5 plus 3, and then I'm going to leave that alone, because that's all I need for right now. Next, I'm going to write the equation for the line that will be perpendicular to the red line. I'm trying to do this blue one. I need it to be perpendicular to the red, and I need it to go through this point, which means my blue line is going to need to have a perpendicular slope, so the blue line's slope will become a positive 3/2. Since it's going to go through the point 2, 7, I can now write that as a y minus a 7, and then I'll have my 3/2, that positive slope, and an x minus a 2. Now, this time, if I distribute that 3/2, I do not get a fraction. So if I want to distribute that, I can do that. And I could say y equals 3/2 x minus my 3 plus my 7. And if I want, I could even clean that up a little more. If it introduces more fractions, do not do any more work. Just leave it like we did on step 1. Now, the other thing that I need, I have my red line, I have my blue line. I need to know where they intersect. That's step 3. So I'm going to take these two equations and I'm going to set them equal to each other. I can do that because both of the equations equal y. So since they both equal y, they can equal each other. So I'm going to have a negative 2/3 x plus 5 plus 3, and that's going to equal 3/2 x plus 4. Now, nobody really likes the fractions on this problem, so we're going to clear them out by multiplying by the least common denominator, in this case, a 6. So 6 times a negative 2/3 is going to give me a negative 4. I still have the x plus 5. I need to distribute that 6 all the way to the 3, so I'll have a plus 18. I'm going to distribute that 6 all the way over here. So 6 times 3/2, I know 2 goes into 6 3 times, so that's going to give me a 9x. And then 6 times the 4 is the 24. Okay. Now I'm going to go ahead and distribute my negative 4. So I have a negative 4x minus a 20 plus an 18, 9x plus 24. I can keep solving. I'm going to move my variables to the right. So I have a 13x. I move all of the constants to the left, collecting those like terms, and I get a negative 26. So my x value is a negative 2. I now need to take that negative 2 and substitute it back into either one of these two equations. It does not matter which one I choose. I can pick either one. So when I substitute that back in, I'm going to get a y equals, I'm mentally plugging it in right here, so 3/2 times a negative 2 is going to give me a negative 3. And I add that 4, and it gives me a 1. So here's my y coordinate, here's my x coordinate. So then when I want to finally find my distance, I'm finding the distance from that nice intersection of a negative 2, 1, and the point 2, 7. Now I can go straight to my distance formula. And I'm doing a 2 minus a negative, or 2 minus 2 is going to be a negative 2 minus 2 is going to be a negative 4. So I'll have my negative 4 squared, and then I have 1 minus 7 is negative 6 squared. So that gives me 16 plus 36. That's the square root of 52. When I simplify that radical, I get 2 square root of 13. And that is the distance from the point to the line. Okay, so in the next video, we'll do the distance between two parallel lines, but I would say this is probably our most difficult.